Again, let's start with the simplest dataset. Use the dataset which is iris right here, 150 instance and 4 features, and all of them are numeric features, and one categorical target is right here. So let's just take a very simple evaluation right here. So we have a test score right here. Want to test several different models, so we simply just pick some basic, very classic algorithm right here. So the next one is neural network. Okay, sometimes we don't want to write programs by using Python. So if these are very easy problems and you want to model a problem by using Orange, which is okay. So we have a neural network right here. So basically, okay, so let's take a look at this table right here. Okay, so again, iris, 3 different classes and 4 features, all numeric features. So we connected the data to here, the test and score, and we have 3 different models: linear regression, logistic regression, SVM, and neural network. Okay, before we continue, okay, let's take a look at parameter of each model. For example, logistic regression right here. Okay, before you apply your logistic regression model, okay, you can choose different regularization types, and here we have 2 different regulation, which is L1 and L2, which is lasso and the range regulation. We have explained what is the difference between lasso and range. Okay, usually we use L2 regulation. Basically, when you using tools like Orange, okay, make sure you select such kind of regulation. Okay, so SVM, okay, we have talked about it before. Okay, they have different kernels right here. Okay, so let's take a look at the neural networks. Neural network model provided by Orange is very simple. Okay, it's very simple, and I believe it can only solve some very basic problems. Basically, I recommend you write your own code by using Python, TensorFlow, or Keras. You don't want to use Orange because the neural network is too simple. So basically, you can see that there are several different parameters you can set in this model. Okay, the number of neurons in hidden layers. So 100 right here means I would like to create a simple neural network which has only 1 layer because it has only 1 numbers, and in this layer it has 100 neurons. We can for example, okay, I change it to 100. Okay, we can apply different parameters on models. So I use another neural network right here, but in this neural network, okay, I write in this way. That means I would like to have 2 hidden layers, and for each hidden layers it has 100 neurons. So we can simply write this, and of course you can choose what kind of activation function you want to use. So basically it says we have several different activation functions like ReLU, hyperbolic tangent, identity. Identity means we don't apply any activation function. Okay, logistic, which means sigmoid. So we use ReLU right here. So the solver means optimizers. We have talked about before. You can choose Atom or SGD or some more complex optimizer. However, they have Orange has only 3 different optimizers. Okay, and we have the regularization. If you want to apply regularization on your loss function, so here's the maximum number of iteration is how many partial differentiation you would like to apply on when you do such kind of training. So basically, the neural network model provided by Orange simply just like that. How many number of layers, hidden layers, and for each layer, how many neurons you would like to deploy, what kind of activation function you like to use, what kind of a solver, which is optimizer, you like to use, and regulation, how many times of iteration, which means differentiation, partial differentiation you like to apply. Okay, so after that, we still can attach the confusion matrix right here. So here's the result, and maybe you would like to add one RC curve right here. Okay, like this. Okay, result right here. Sampling right here, we usually use cross validation, which means tenfold cross validation, which means again, okay, we partition the original training data into 10 different data sets. We use 9 dataset for training and 1 part for testing. And we do such kind of partition 10 times. Okay, we iteratively replace the testing data. So here's the result, and we can see that for such kind of simple data, iris data, okay, so the classification rate right here, they're quite high because this is very, very simple data. Again, and we can see that if you apply different parameters on neural network, for example, this model has 2 layers, each layer has 100 neurons, and this neural network is much simpler. It has only 1 layer. Okay, the classification rate is different. Of course, it says that it is not necessary that you have a very, very complex neural network and you guarantee has a better classification result. The statement is wrong. It's not correct. For example, we can simply just add more neural network right here. For example, right here. And if I have 10 neurons, but maybe 30 neurons, 20 neurons, 10 neurons, and I apply, that is good enough, I think. Okay, just a test. Okay, so I'd like to see what is the difference between layers and neurons. The results like that. We can simply just ignore those things. I think that is not important. Okay, so we have 3 different neural networks, and each of them has different settings. Okay, so we can see that because it is a very simple data set, so it does not reflect the relationship when you using different number of layers and different number of neurons. Okay, so maybe we can try some other interesting things, such as housing, maybe. Okay, and for housing, then we can see that all of them are still numeric data, right? The target is right here. Okay, target is right here. That's good. Since the target right here, okay, as mentioned, since the target is numeric data, so we don't have classification result. Okay, we don't have such kind of things. We can simply just take a look at this one. Okay, and also we can choose MSE value or square MSE value. If we have smaller MSE value, which means your prediction data is close to your true data, true target. Oh, so you have a lower MSE. So we can see that we have different settings of neural network right here. Okay, 2 layers, 3 layers, and different neurons right here. It is not necessary. It means if you have a complex neural network, for example, for me, if your network is more than 3 hidden layers, and I will call it deep neural network. But it does not guarantee that your MSE is lower than neural network, which has only 2 layers. Okay, so basically you can try yourself. Okay, you can try different. For example, maybe we use some other activation function right here. Okay, so I said 100 right here, and I said it's hyperbolic tangent. Okay, so I connected this one to here. The result. Okay, so again we sorted by MSE. So it means okay, you can see the difference when you use ReLU or you use hyperbolic tangent. Okay, the result is different. So sometimes you need to try how many different layers you would like to use, and for each layer how many neurons in each layer, and what is the activation function you would like to use, because different activation function has different result. So sometimes try, okay, try it yourself to see the difference between different design of neural network. Okay, that is. So that is the neural network you may want to use, but that is the only parameters you can change right here. Not much. For example, if you want to apply convolution neural network, you want to apply max Boolean, no. Orange does not provide such kind of layers. Okay, they are simply just a very simple layers. That's it. If you want to apply different layers, different types of layers, you have to use Keras or Python by yourself. And also here is an option right here, and here we have add-on options right here. There are several different add-ons that can be downloaded from the network. So make sure you have your text, which is right here, because we like to analyze text-based data. We mentioned it before. When we analyze sequence data or time series data, we have several different techniques to help us to analyze sequence data or time series data. For example, we can use one-hot encoding. We can use one-hot 2-gram encoding. But however, if it is a text For example, it is a book, it is an article. So we have several different ways to transform the original text-based data to numbers. And after we have numbers, then we can apply different models. Because for example, SVM, linear regression, neural network, all those models we taught in this class, most of them deals with numeric data. We don't directly input apple, this word, to neural network, because neural network does not know what apple is. You have to convert your original data, which is text, which is a sentence, which is a paragraph, which is an article and document. Okay, and you click OK, then Orange will download the Orange text libraries from network. If you correctly installed the things, there should be one more tabs right here, which is text mining, and we have a very useful tools. Make sure you have those features. Basically, they help us to deal with some corpus. Corpus 中文就是文库哈，文集啦。So we'll introduce several different features right here. Okay, so let's first take a look at this tag. Okay, text mining. Okay, originally we usually we drag the file right here, right? So we can see the file informations by using the data table like this. Okay, so that is the housing data, right? But when we analyze text, okay, we don't use file. Okay, so here's the corpus right here. Of course, there is a viewer which was here. Okay, so since we don't have numeric data in text mining, okay, so we have another new corpus viewer. So we connect it together. We see that okay, we have several different corpus file. Okay, right here. Unfortunately, we have only 5 different preload corpus right here. Of course, you can use your own corpus. So, for example, we use the first one. Okay, it's tales. 这是格林童话嘛 Okay. There are several different information right here, and we can simply just click corpus viewer. Okay, so as we can see that here are 44 documents. So each of them they have a title. So title is right here. So when you click different documents, we say articles. Okay, there are several different features right here, including all is the ATU topic right here, which means all these tales about. So that's a tale about magic. So tales of magic. Okay, and its title, and there's a very simple abstraction. It's only one sentence, and here's the content, which is the corpus itself, document itself. For example, magic is title, is very simple, abstract, and its content. So the data format is a little different. Okay, usually in previous analysis, we use numeric data, right? Calculated data, but in text mining, okay, data looks like this. So we have 44 different articles. And what is our target? For example, we can use a model to analyze the information right here, abstract, title, and content, to do a classification, to classify, okay, what kind of topic this document belongs to. For example, here is the tales of magic, okay, animal tales, what else? Okay, at least we have 2 different categories. So we use the ATU topic as our target. So that is the corpus. So when we analyzed a corpus, what is the first thing we like to do is this one. Usually it's called word cloud. Okay, so put it right here, connected the corpus to the word cloud. The word cloud will create an image. Okay, an image right here like this. So it simply just count how many words in the corpus and what is the frequency, which is the weights right here of these 44 documents. So as we can see, the most popular word used in this corpus is this word, the 4,346 times, and some punctuation is right here. However, such kind of information is useless because as we can see that for the first 10, we say words, they are just some very general normal words, right? So usually when we analyze a corpus, okay, we can insert a widget right here, which is preprocessed text, and also it's right, I think it's right here, right? It's right here. Okay, it will remove some normal words. So let's take a look at this one. Okay, we have several different preprocesses can be done right here. Okay, the first one is transformation. Usually, okay, we select this one, lowercase, which means we do not differentiate capital words. So we transform all the words in a document to lowercase. And sometimes we check those button, those checkbox, okay? Remove accent. So for example, how do you spell realize? R-E-L-I-S-E-O-I-Z-E. Okay, they will have a database to make sure these two words will be represented by only one words. Okay, remove accent. If your document is downloaded from the website, maybe your document is represented as HTML, which is a format of web page. Okay, so you can parse HTML. They will remove all the HTML tags and style. Okay, so only words will be left in your corpus. Okay, they will remove all those HTML tags and JavaScript, and of course you can remove URLs if you want to do so. Okay, that is transformation. The second one is called tokenization. Because we input a document, okay, and this document has several paragraphs, and for each paragraph there were several sentences. In each sentence there were several different words. So how do we tokenize those words? Usually you can partition this word by a regular expression, which is right here, which means I would like to partition those sentences by using punctuations, white space, and something like that. The words such as he, she, the, to, is, are, something like that is a little bit useless when we analyze a document, because they are necessary and normal words that you have to use in a sentence, but usually it does not have semantic full meanings. So those words are called stop words. Okay, so it has a predefined database that has defined several stop words which you would like to filter out those words when you analyze the document. Okay, of course you can prepare another new document that has all the stop words you don't want to analyze. You want to filter those stop words out. You can define your stop words. Okay, so you can select your database right here. But we use the default one is good enough. So after that, you can see that we have two different word cloud. Okay, the original one, which is like this. Okay, and you can see that there's some irrelevant word. Okay, those are stop words which we don't want. So after you apply those things, preprocessing. Okay, we can see that those words are much more meaningful because punctuations, white space, capital words, those words will be removed. Of course, you can define, for example, you don't want the word sad. You want its word to be filtered out. You can use your own stop word list and put the set in this stop word list, and you can filter it out. This one. Okay, the document frequency means we remove the data of the words which is higher than 90% and less than 10% of occurrence of frequency. Okay, if you want to remove the most of frequency, you should use document frequency because it only kept from 10% the words that use in 10% between 90%. Okay, so that is so this word cloud will be much better. Okay, will be a little bit much better than this one. Okay, so usually we don't use this one. We use the preprocessed one. Okay, so that is the preprocessing. We can still use the data table. Okay, to observe the corpus after we do preprocessing. So it looks like this. Of course, we have 44 documents, so we have 44 rows right here, and here's our target, which is our topic. Okay, it is either Tales of Magic or Animal Tales, and here is the title right here. Is the title. Of course, they are all text. They are not numeric data, abstract and content, something like that. Okay, so that is the original data. But if you connect the data table after the word count, okay, and you can see that how many words are counted. Okay, so that is this. Okay. So the next things, but usually you just output those the things. Okay, we don't. It's not that useful. Okay, so that is. So next one is bag of words. It's right here. Those are simply just help you to know what kind of words has been used in your articles, right? So how do we transform the text-based data to numeric data? So that is the first mechanism called bag of words. So we connect it to here, and we connect a data table right here. Okay, so let's take a look at this one. The information will be converted to more richful. Okay, those things are original. These columns. Okay, topics, title, abstract, content, something like that. That just the old things. Okay, after bag of word. Okay, a new column will be right here. Okay, however, this column is a little bit different, a little bit strange. Okay, it records. Okay, those words. Okay, as we mentioned before, we have a word count right here, right? We have a word count right here, right? So basically, how many word counts? How many words are listed here, right here? Okay, and you can see that 3,719 words are counted in our corpus. Okay, in our corpus. If you want to remove all those words that only exist in our corpus once, okay, you can select, as I mentioned before, you can select the preprocessing. Maybe you can click this one. Okay, after that, you can see that the word count changes. Right? In this case, only right here, only 907 words will be considered. Okay, because the word with too many frequency count will be removed. The word with too less count will be removed. And when we want to use some numeric data to describe an original document, okay, as we mentioned before, if there is a feature that its variance or standard deviation, its variance or standard deviation is very high or very low, that means this feature is useless because everyone has this feature. So usually we will apply this preprocessing right here. We want to remove the words which appear in all documents, and we like to remove some words that only appear once in a document. After that, you can see that it changes. Okay, we only have 900 words. Okay, so the data table right here, it is a list. Okay, it is a list. It's for each rows. Okay, in this column, it has 907 words, and this corresponding frequency count will be listed right here. So in this document, able occurs once, afraid once, ago once, as which I don't know what it means, 7 times, blah blah blah, and etc. And would like to use the information in this list to describe the article numerically. So the next one is, let's do evaluation first, which is okay. The same thing. Okay, we apply 2 models. For example, regression models right here. We use SVM model right here. So basically, it's the same. Okay, we connect the model right here. That is the input data right here. So basically, the logistic regression and SVM, they will use the features provided by bag of words, which is the 907 columns, and each columns in each cell is the occurrence frequency of the word that used in the document. Okay, they will use such kind of information to do logistic regression and SVM. The target, as I mentioned before, the target is the topic. Then we can put it right here because it's a classification problem, right? So we can see that we have 2 different models right here, and the classification rate for logistic regression. Okay, among those 907 features. Okay, the classification rate of the topic is 90.9. 90.9%. SVM is not that good, 84.1%. Okay, so configure matrix looks like this. Okay, for the logistic regression, okay, we have 44 documents, right? So this cell means there are 18 documents. They are actually animal tails, and the predict model by logistic regression, 18 of them are classified as animal tails, and 4 of the documents are misclassified. Okay, so SVM is not that good because 7 documents are not classified into correct topics. Okay, however, we can still see some information about the misclassified ones. So let's take a look at the table. It should be connected to right here. Okay, and we can see that we have 44 documents, right? So here is the result. Okay, we have 2 models right here. So which is the result of logistic regression, the result of SVM. Okay, here is the probability for this example. Okay, originally it should be animal tails because it describes something about bear. Okay, however, in our SVM it says it is a magic tail because the word used in this document, and we do some machine learning, right? So machine learning, the SVM says, okay, the word used in this, the widow, worm, and the bear, it's much more like a tale of magic. That's because, you know, the word they use is more like a magic tale. Maybe that is because the bear can talk. It really depends on what is the word the writer choose to use. So that is how we use back of words technique to convert the text into a very large feature table, which has 907 features. So what else we can do for text mining? So next things we can do is clustering. We can still do something about unsupervised learning after we have backward words. So let's remove these things to right here. Since we have the table, right, 907 features, so we can do very simple distance metrics. I would like to remind you how do we do hierarchical clustering. So maybe there is a file and we have the iris data right here. We can use the 4 features right here, and we can perform hierarchical clustering after we use this. Right, after we calculate the distance metrics. So basically we can do such kind of things, right? But how do we do hierarchical clustering by using the result backward word? It's the same. So we simply just connect a hierarchical clustering after the distance function. If we use the same technique, cluster the different document based on the 907 features. Okay, we use the 907 features to create a space, right? Has 907 dimensions, and for each dot in this space is a document, and we measure the distance between each data point. So we cluster them together by using hierarchical clustering. So the result will be like this, and you have to design a distance, okay, in your hierarchical clustering result. And for the groups, for the cluster, which their distance is lower than certain value, okay, there will be cluster. So in this example, okay, maybe we set the value right here. Okay, so we can see that there are 3 different classes: C1, C2, and C9, and there are some other tails that cannot be merged to other cluster. But however, we can see that the document in cluster 2, they are all tails of magics. That means the word they used, they are much more similar with each other. That means in that 907 dimensions, the data point, they are close to each other. And of course, there are another cluster right here. I think there's another cluster right here. The word they use is a little different from the word they used right here. So they have 2 different clusters right here, right? This one and this one. But they all falls into the class of tales of magic. Okay, however, we can see that for this cluster or for this cluster, Okay, we can see C1 and C2. C1, they are all animal tails, which is good enough. But for C2, some of them are tail of magic. Some of them are animal tails. So let's take a look at, for example, so we can connect a data table right here. After the hierarchical clustering, it will output the selected data. So it's right here. We say that most of them are animal tails, but part of the document in this cluster, they are magical still, because the word they are using are more like animal tails. I don't know if you are good, if you know much about those tails. Maybe you can tell me the queen bee is the word it used is more like animal tails, not like magic tails. We can do prediction, right? So let's take a let's create a model right here. Here's a model, logic regression. Create the model, okay, by using the backup word, okay, and we can use this model with different corpus right here. For example, the original training corpus is Greenman, right? So we use another similar things, Anderson, Anderson 童话, huh? Anderson right here. We do a prediction, so prediction is right here. So we use a linear regression as a model to learn how Grimm corpus and its topics, okay, by using backup words. And then we use this corpus, which is Anderson, to help us to do prediction. Okay, we connect the result right here. That means, okay, Anderson is a very small corpus, right? So it has only 3 documents in the Anderson tails, okay, in our corpus, okay. So the first one, the prediction result by logistic regression. It says, okay, it's 98% of probability is more like animal tails, okay. For the second one, it's a 99.99% is magic tail, and this one is that 91% is animal tails. We can still use prediction when we apply text-based data, because after backup word, they are no longer text. They will become a 907 feature. Okay, so that is prediction. Okay, semantic analysis. It has several different English words, and it will has a score after this English word, which indicates this word, the meaning of this word is positive or negative sentimentally. So for example, good is a nice word, and some, for example, frustration, which means the sentiment or 对它情感 is not good. So there's a database. So here is the sentiment analysis. So let's remove this one to here. So we use a smaller corpus, okay? Okay, the result is right here. So it is connected after a corpus, not deck of words, okay? Because it only deals with, they don't deal with the numbers, it only deals with the words they used. So the result is right here. So that means this article, okay, this article is right here, right? This article sounds positive or negative or neutral. This kind of analysis just simply map all the words and the original corpus. They will look up a database. The database says, okay, this word, okay, is negative. For example, minus 0.1. The next word they use, for example, happy, is a positive word, which is plus 0.7, and they will do a weighted score. So the result will be like this. So as we can see that those tails are they most of the time they use neutral words. And of course you can choose another corpus and see the result of different. For example, we can see what is the best, what is the most positive, what is the most positive tails that where is it here? This one, okay. The Elvis and the Shoemaker, okay, that is the most positive tails in this corpus because it is a very high positive score. So let's take a look what else we can do. Okay, so that is another one. So let's take a look at the document embedding. Okay, So let's take a look at the corpus we use. Still, we use the gram corpus. Okay, so here is the document embedding, which means there's another way to transform those text-based data to numeric data. Okay, of course, bag of words are one of the way to convert the original text data to numeric data. However, there are some other ways to do such kind of things. Okay, so you can simply just connect this one to here. So this document, of course, there are several different algorithms that can convert the text to numeric data. However, there are some very well-known algorithms that we use them quite often. So you can simply just apply those algorithms, which is document embedding. It takes some time because it reads all the words and all the documents, and it will try to find a best representation, which is a numeric data. Okay, so let's take a look what is the result of such kind of embedding. Embedding means convert the original data to another new linear space. We have described what is linear space before, right? So you simply just take a look at this one, and you can see that the original data is right here. However, you can see that. Do you see that? Okay, there's a 300 dimensions, and those values are purely numeric data. Okay, and we use these 300 dimensions and those numbers to represent the content right here. What kind of algorithm they use? Actually, I don't know. Maybe we should check it in the Orange's official website. Basically, if you want to do the same thing, such as right here, you want to do hierarchical clustering, do the same thing. Okay, you can connect it to the distance function, and then hierarchical clustering, and then you can see that again we have a very nice clustering result. Okay, which is right here. Okay, however, I do not recommend to use this this kind of unknown models. Okay, but it is one of the way to convert data. Okay, I think that is most of the things we might use in text mining. So let's go back to our website right here. So you can see that here is a data set. Okay, here is a corpus. Okay, the corpus right here is spam mail data, which means you can see that right here. Okay, we don't have to in this data set. Okay, it has several different columns. For example, there are 48 attributes. Attributes means data. Okay, they are numbers. Okay, they are numbers from 0 to 100. They present the percentage of words in the email that match words. That means this data set already gives us preprocessed data set. Okay, there are several emails, spam mails in the data set, and it's in this email data set. Okay, they count specific words. There are 48 specific words, and their corresponding counts right here. Okay, of course there are certain things, and at the last there is a column called nominal. Okay, it is either 1 or 0, which indicate it is a spam mail, or it is a spam mail, or it is not a spam mail. So basically, you can collect a lot of email, no matter it is spam mail or it is a normal mail. Okay, you can create such kind of table manually. Okay, you select some words, which is very useful for us to do such kind of prediction. Okay, you can design your own table to describe the data. Okay, or you can simply just use the tools right here, bag of words. Okay, oh sorry, this one, bag of words, or you simply just use an unknown model, which can give you a 300 dimension vectors to represent email. Okay, and then you can apply any supervised learning or unsupervised learning data to help you to cluster spam mail or normal mail, or help you to do classification to classify spam mail or normal mail.